Hello students, welcome back to our channel Mathix Infinity. Today we are going to discuss a very interesting problem from IIT Advanced 2020. Given a function f which is of the form uh, f dash x equal to fx by b square plus x square and which satisfies f of 0 is equal to 1, then which of the following options are true? Option A, if b is positive then f is increasing, and if b is negative then f is decreasing, and option C, that product of fx and f of minus x equal to 1, and option D, that is f is an even function. So dear students, first you should try this problem yourself, and after a sufficient number of tries you should see this video. Okay, so just uh, proceed with this problem. So students, first uh, we have to remind a very basic theorem of differential calculus, that when a function become increasing or when a function become decreasing. This is a very basic and important theorem from differential calculus, that a function fx is increasing if f dash x is positive and decreasing if f dash x is less or equals to 0. This is a very basic theorem. So students, in order to check that option A and option B, that is when this function f will be increasing or decreasing, we have to check the derived, derived function, that is f dash x, whether it is positive or negative. Given f dash x is of the form fx by b square plus x square. So the denominator is always positive, but we don't know about fx. Fx may be positive or negative, or somewhere positive, somewhere negative. So we have to solve, and we have to uh, uh, eliminate the form of fx. Okay, so we have to solve this differential equation. For simplicity of this problem, let us assume y is equal to fx. Then this equation 1 becomes dy by dx equals to y by b square plus x square. So students, to solve this problem, we proceed with the method of separation of variable. Just take dy by y, that is dx by b square plus x square, and integrating both sides, we have log y equals to 1 by b tan inverse x by b plus c. So this is the solution of this problem, and look at this solution, and there is a given condition that f of 0 is equal to 1. We will use this condition to find the value of the constant c. F of 0 is equal to 1 means at x equal to 0 y is equal to 1. So just put these values here. Log 1 is 0 and tan inverse 0 is 0, so obviously c is 0. So the solution is log y equals to 1 by b tan inverse x by b. That is y is equal to, which is fx, e to the power 1 by b tan inverse x by b. And students, we know that a exponential function always positive. This is exponential, and for all values of x, this will be asymptotic at uh, as x tends to infinity, and always positive. So we can say that if x is always strictly greater than 0 for all x. There is no value, no condition, or we can adapt using separate values of b. So if x is positive, what it will be the value of b? It will be always positive. So uh, from this thing, we can say that if from 1, f dash x is will be always positive, because fx is positive and denominator is positive, so f dash x is strictly greater than 0 for all x in R. So fx is increasing. So our option A is true. uh, for if b is greater than 0, then f is increasing. But if b less than 0, then fx is also will be increasing. Okay, so option B is not true. Now we will check option C, that is fx into f of minus x will be 1 or not. So what is our fx? Just now we have derived fx equal to e to the power 1 by b tan inverse x by b. Okay, and what is f of minus x? It will be e to the power minus 1 by b tan inverse x by b, because we know that tan inverse minus x equal to minus of tan inverse x. Okay, so it, fx into f of minus x will be e to the power 0. Okay, it's 1. So option C is also true. Option C is all. Now option, we have to check option D, that is whether f is an even function or not. Clearly f is not an even function, because f of minus x is equal to e to the power minus 1 by b tan inverse x by b, which is clearly not equals to fx. Okay, so option D is incorrect. Another way to check this problem, that using condition C, that is if option D is true, if D is true, then f of minus x will be f of x. And since option C is true, since just now we check C is true, then from using condition C, we can say fx whole square is equal to 1. That is fx equal to 1. Just using this continuity of this function, we can say this fx equal to 1. So fx is a constant function, but as we can see that fx is not a constant function, so option D cannot be true. So our correct option is option A and option C. So this is the problem. I think students, you understand this problem. If you have any kind of doubt, you can comment. Thank you.